All right, let's do an example for our proportions, okay? So here we're going to run a research trial for a new migraine drug, and we ran 60 trials and see success in 40 of the trials. So the first part of our example here is to try to find our point estimate for the population proportion, okay? Now, if we recall, the point estimate is what we're going to be doing is the value that we're using to estimate our population proportion or that population parameter. So here, because we're looking at population proportion, that point estimate is going to be p hat, okay? This p hat is defined as our number of successes over the sample size. So plugging in our values, we saw that 40 of the trials had success. So that's going to be in our numerator. And our denominator shows that we have 60 trials that were ran. Okay. So we're left with 40 over 60. And showing a quick calculation, we see that p hat is going to be equivalent to 2/3 or 0.667 or 6 repeating. Okay. That is our point estimate for the population proportion. Yes, that's right. Okay. The next part of our example here is to find the mean and the standard error based on the sample proportion. So, as we recall, our mean is going to be equivalent to whatever the population mean is, which is equivalent to our population proportion. And then that standard deviation, or that standard error, is going to be equivalent to that equation above as well. Okay? The square root of p hat q hat divided by n. Okay? So the mean is going to be whatever that population proportion is. Here that is unknown, but we can make an argument for it to be the point estimate in our case for now. But we're going to leave it as it is for this example. And we're going to focus more on calculating that standard of error. Okay? So let's rewrite our equation of the product of p hat q hat all over n, and then we take the square root of all of that fraction. Let's write out our variables on the side here. We have uh, 0.667 or 2/3 for our p hat, and our q hat is the complement of that. So that's going to be 0.333. To visually see how we got that, we're going to take the complement of our p hat, and which is 1 minus our p hat. And finally, we want to have our sample size. So here, the whole sample size is the amount of trials that we've done in our research trial study, which is 60. Okay, so that means that our standard error is going to be equivalent to the square root of 0.667 multiplied by 0.333, or 2/3 times 1/3, all over 60. Calculating the inside of our equation, it's going to be 2/3 multiplied by 1/3 divided by 60. We have a pretty small decimal there. It's going to look like 0.0037, but let's take the square root of that. And we will get 0.061 about. Okay. And that is our calculation for the standard error. Okay. Part C, find the maximal margin of error. And here I added the part for the confidence level that we would like, which is going to be that 95% or 0.95. Okay. So as we know, the maximal margin of error equation is going to be this equation that is in green, which is going to be our critical value multiplied by our standard error. Okay. Thankfully for this critical value, we actually solved for that value back in 7.1. But as a quick recap of all of those steps that we did, we drew out the standard curve, found the area to the left of the negative critical value using the inverse normal distribution, I'm sorry. And that was our critical value. So here, I'm going to rewrite that value that we found. If you'd like to see that calculation done again, please review that section where we did the example for finding the critical values. And that value was 1.96, okay? Our p hat, q hat, and n, we actually don't really need those, is 2/3, 1/3, and we don't have a such thing as an n hat, so I'm gonna fix that. We get 60. This, recall, was our standard error. Well, specifically in that equation, it's everything that's underneath the square root here. Which we found as 0.0161, okay? So, our maximal margin of error is going to be 1.96 multiplied by that value that we found in B. This should be equal to, let's calculate it, 1.96 times 0.061, 0.11956. So I'm going to round it to 1.2, just for simplicity. Okay. Last but not least, we want to find the 95% confidence interval for the population proportion. If we recall from our equation above here in yellow, our confidence interval is going to be the maximal margin of error that we found, and we're going to add it and subtract it from our sample proportion. Okay, so I'm going to write that out. Okay, we know that this is 2/3 plus or minus 0.12. In fact, I'm going to write this out as a decimal because our margin of error is written as a decimal. Okay. So, as we recall, our our confidence interval is going to be the sample proportion minus our maximal margin of error and added to it. So numerically, that is going to look like so in our equations. And plugging those numbers into our calculator, we are going to get a confidence interval that looks like so. Okay, and that concludes our example for finding the confidence interval for a population proportion given a sample proportion.